Welcome to codeLive. I am very excited to be back online with you all. Thanks for joining. All of you that are in YouTube live right now, please go ahead and say hi in the chat. Let us know where are you right now in this moment. Good morning, good afternoon, good evening to you. It will be my afternoon for me. It is almost 1 p.m. here in Tampa, Florida, in the United States. But go ahead, say hi, tell me your name, where are you joining from, and let's get together this new episode of codeLive. I want to thank Kevin Purman. He is our previous host of codeLive. As you might know, he recently left the company to pursue other projects, but he left a very good legacy with codeLive, and we want to continue with it, like having weekly live streaming, live coding, teaching you Salesforce and programming concepts. So I am back. I am not going to be alone, obviously, teaching you about programming and developing on the Salesforce platform. There are going to be a lot of other people that is joining me in the future. But I'm going to start this new codeLive series with something that I'm very, very interested in, which is Elastic Services and Salesforce Functions. So we are going to have a series of episodes. I have planned like maybe 5 or 6 so far, when we are going to be exploring how to access Heroku Data in functions, how can we invoke functions on using certain advanced patterns, how can we create recipes for the function recipes project, and more other people from the team is going to join me during these streams. So let me go to the chat to see who is connecting with me. So we have Enrique. Hello, Enrique. Thanks for joining. Juan P. Rodriguez also. Seikat, Sasha, Augusto, Mohesh. Hello. Welcome. We have people from Belarus, from Brazil, from Iraq, from Nicaragua, from India, from Cuba. Oh, this is amazing. People from all over the world, and that makes me super, super happy. So, without further ado, let's start with today's topic. Now, let me switch here on this screen. So before I start talking about functions and upcoming things that might happen, if you have been around in the Salesforce ecosystem for some time, this might be familiar to you. Remember, Salesforce is a public traded company. That means that I might be talking about certain future or upcoming features of the platform. So please don't make any financial decisions based off the things I am going to tell you today, only of things that are generally available, right? Well, what are we going to be taking a look today is how to access Heroku Data from a function. So functions are a way of extending our Salesforce applications using elastic computing or serverless computing. So we can write functions using either Java or JavaScript using the Node.js runtime, and we will be able to connect those functions with our Salesforce org. Sometimes we will need to access data from those functions. What type of data? Normally, we are going to access Salesforce data through either the SDK or the REST APIs, but sometimes we might need to integrate with third-party applications that are using, let's say, PostgreSQL, Redis, or some other like streaming data capabilities like Apache Kafka. Heroku provides those 3 open data platforms through their service, through their platform as a service. So we recently launched a way to connect those data sources like PostgreSQL, Redis, and Apache Kafka to our function so we can have like a more integrated and powerful solution. So before you start, I'm going to be doing some live coding, experimenting, showing you how to create a Salesforce functions project, how to create a function from scratch, how to connect to a Postgres database. We are going to be doing some experimentation, but if you want to do it yourself, this is what you need. So first, you will need an Heroku account. This Heroku account is going to be for free. You can go to signup.heroku.com, create your account. We are going to need this for a couple of things. First, in order to have access to a PostgreSQL database, you will need to create an Heroku application. So make sure you have an Heroku account and also the Heroku CLI because we are going to be using that one. Also, we can do these experiments in two ways. One is going to be locally, like on our computer without deploying the function, or we can deploy the function to a Salesforce org. For that, we will need to have an org in Salesforce that have the functions feature enabled. There is an ongoing trial that you can go to functions.salesforce.com/signups and sign up for one of the trials. The trials has been very popular. A lot of people have requested trials. So maybe you might need to get into a queue to wait until one of those trials becomes available. But don't worry, if for some reason you don't get a trial, keep trying. And the things you are going to learn today are going to be useful because I'm going to teach you how to do it locally. Also, we will use Visual Studio Code with the Salesforce extensions. This is going to facilitate the developer experience for us so we can create the function, execute the function locally, and obviously create our code. We will need the Salesforce and the Heroku CLIs. The Salesforce and Heroku CLIs are pretty much the developer tools that we use to create Salesforce projects, deploy Salesforce projects, etc. And depending on the language of your choice, the language of my choice is Node.js or JavaScript, but depending on the language of your choice, you might need to have installed in your computer Node.js or Java. I have both. I'm going to be doing my examples in Node.js, but maybe if time permits, we can create a Java function and access the PostgreSQL database from Java. And also, we will need to start by creating an Heroku application with the Heroku create and the name of the app. But I'm going to be showing you those different steps during the stream. Okay. It's Sasha asked, functions will be presented in the upcoming releases. What do you mean by that, Sasha? Let me know. Okay. Let's continue. Salesforce Functions loves Heroku Data, and that's what we are going to be showing you on this episode with PostgreSQL, the next week with Redis, and in 2 weeks with Apache Kafka. So, my name is Julian Duque. I'm a principal developer advocate here at Salesforce, and welcome to codeLive and to this new series of Heroku Data in functions. Okay, so let's start with a Salesforce project. So let me go to the terminal. I'm here on an empty folder, which is functions, and I'm going to be creating a new project. What we need is the Salesforce CLI to be able to create that project. But we are going to be using the new SF command. The new SF command comes automatically with the newer releases of the Salesforce CLI. So make sure to update your Salesforce CLI by running sfdx update. This will give you the latest version so you can use SF. So confirm that you have sfdx installed in your computer by running sfdx version and that you have SF installed in your computer by running SF version. See, I have the two CLIs. I'm going to be using SF to generate and create the project. So let me go back to the terminal. Cool. And let's create a project. So SF, I can take a look at the help of this SF command. And here we have a subcommand to generate projects or functions from templates. So let's take a look at the help from SF generate. And here we can see that we can generate either a project, which is a Salesforce DX project, or a function. So we are going to be using these two commands. First, to create a project. Second, to create a function. So let's create the project. SF generate project. Let's see what parameters do we need. It requires a name. So let's give it a name. Let's call it Heroku Data. I like this name. And this will generate a folder with the necessary files to start creating Salesforce applications. So far, this is a regular Salesforce DX application that you can deploy to an org, to a Scratch org. It doesn't have any functions enabled. Later, we will add the function. So let's go to that Heroku Data folder and open Visual Studio Code. Come here, Visual Studio. Awesome. So let's explore this project for the people out there that have never worked with a Salesforce project. So here we have the project description. It is telling me that, sure, this is a Salesforce project. It has a name. This name is going to be very important for functions, because the functions, when they are deployed, are going to be attached to this specific namespace. Let me close these error messages here that we don't need and open a terminal. Perfect. And this template, it seems, is giving me an older API version. I'm going to update this to use the latest API version, which is the 54. And that's it. We have a basic Salesforce project. If we want to work with functions and deploy these to a functions org, we can either deploy directly or create a Scratch org. We are going to be creating a Scratch org against a trial org that I have already created that has functions enabled. So let me join to my org and show you how can you make sure that you have functions enabled once you get access to the trial org. So I'm going to log in .salesforce.com, log in to my trial. Perfect. I am going to set up. And hitting setup, I'm searching for functions. And here in functions, we have the information of the environment that our org is connected to. So this is telling me that we have functions enabled. In order to create the Scratch org, you will need to enable both the test space and also, if you want to deploy to a production org, you will need to enable the production space. So these two things are going to be disabled by default. You will need to enable those. Make sure to do it after you get access to your functions org once you apply to the trial. Oh, Sasha, yes, functions already exists in platform. This is a feature that has been released. Right now, it is under a license. So this is what I'm mentioning you, that you can get access either through a trial, or if you have access to an AE, the AE can give you a courtesy license. Here is where the forward-looking statement comes in. The functions team is working on a freemium version of functions. So you will be able to get like a free version of functions so you can deploy, and this is going to be available in the future. It is not available today, right now, only through the trial, but the team is working very hard to get the freemium version out there so more people can benefit about Salesforce functions. Okay, we have functions enabled. Normally on a trial function, you get access to the function recipes project. So what is the function recipes project? I'm going to do like a quick introduction because I have a full episode where I'm going to be doing a walkthrough this specific project. So we created this project to teach you about Salesforce functions. Here you have different examples written both in JavaScript and Java that shows you how to write functions that are connected or integrated with Salesforce. For example, I have a simple function that gets the organization info or the org info from the org that it's calling or executing this function. If I execute this function and if everything works, I am getting the data, like this function is being executed by this specific organization and by this specific user. So this is just the API that it is available for us. Or you can also perform queries from a function. Here, we are using the data API SDK that it's available on the function to query information from my Salesforce org. So I can pretty much execute this, provide a keyword, and it will return data. Right here, it's returning information. It's doing a query to the account object, and it's returning an account called Testing Vivek. It is an account that it's created here. So that's a way that we can access from either Java or JavaScript to our Salesforce data. And we are not setting any authentication token. We are not doing any configuration. Functions already run on a trusted environment. By using this context object, I have access to an SDK that it's already authenticated. And pretty much the event here, as you can see here on line 20, the event contains the data that it's coming as the input of the function. When I'm calling this function, and if I'm calling Vivek, for example, as the input, I invoke the function and it is getting that keyword and using that keyword to do the query, pretty much. So that's an introduction of functions. You can also integrate functions with Lightning Web Components, Flow, platform events. We are going to see this in the future. For example, here on a Lightning Web Component, I am going to invoke a function to get results from a JSON database and rendering those results on the screen. So you can rely on functions to perform high compute operations. And one of those operations is accessing third-party data or external data that is located on other databases, for example, PostgreSQL. And we are interested today on learning how to integrate a function with PostgreSQL. Okay, let's get back to our project. I told you, let's do everything local right now. So let's assume that we don't have a functions org. How can we do all of this without an org? There is the local development experience. I'm going to be sharing a blog post and later we will add it to the description of the video. And there is a link that I already shared with the Spencer, one of our moderators, which is, let me see here. It is the Developer Center for Functions. Here you can get access to all of the documentation, different videos, code samples, other resources that we have created for you to learn about functions. This is part of the developer.salesforce.com website. You can go to Discover, scroll here, click on Salesforce Functions, and here you get all of this information. There is a blog post that I wrote. Let me go to the blogs, which is getting started with Salesforce Functions locally, no license required. This is a full tutorial where I am teaching you how to run functions locally without needing a license. You can do this against Developer Edition org without having any issue. The only caveat is that you cannot deploy the function to an org, or you cannot call the function from Apex. You are going to be invoking the functions from the CLI. But that's okay. For development purposes, it is okay. When you develop the function and you make sure that the function is doing what you need to do, then you can deploy and integrate it with your Salesforce code. So how can we do this? So first, we need a function. So let's create a function. In order to create a function, we need to be in the Salesforce project folder. So right now, I am in the Salesforce project folder. You can do it using two different methods. If you are using the Visual Studio Code extensions, you can do the command palette, which in Mac is Command-Shift-P. And here there is a command called create function. This will ask you the questions to create the function. It will ask for a name, then it will ask for the language, and then it will create the function. Or you can use the CLI. I prefer the CLI, but if you like the Visual Studio extension, please go ahead and use it. Let me increase zoom because it seems a little bit small on your screens. Ravi, what is the heap size for functions? What is the max size the functions can hold in runtime memory? 1 GB is the size of memory for functions. It's 1 GB. But they can scale, but normally it's the execution is 1 GB. Okay. PWD, this is my folder. Let's generate the function. So run sf generate function, give it a name. We are going to be working initially with JavaScript. So let's call this Postgres JS, and our language is going to be JavaScript. Things to take care here is that the name of the function needs to be in lowercase. That's important. Name of the function in lowercase without dashes or underscore, I think is not supported. Lowercase, one word. And the language, it's going to be JavaScript. So this will create a folder in our project called functions. Now we have the folder here, and it will create a project for that function. This project, since we selected JavaScript, it is a Node.js project. If you are a Node.js developer, this might be familiar to you. You have a package.json. Here in the package.json, you will specify the dependencies of the project. It also has a folder with some mock tests. Test written using Mocha, which is a test runner for Node.js. And you have the index.js file, which is the main file for the function. And the basic hello world example that this is giving us is a function that it's performing a query against an org and returning the information of the accounts that are on that specific org. That's the basic hello world function. We have some instructions here which is before creating a Scratch orgs, make sure you enable functions in your DevHub org and add functions to the future list in your Scratch org definition. Let's do that before we forget, because obviously I'm going to forget in the future, so let's add that immediately. So go to config, the Scratch org definition, and add function as one of the features. Okay, now if we create a Scratch org, it will have the functions feature enabled. Cool. We have the first function created. Let's execute it. How can we execute the function? How can we run the function? So locally, there are like two steps. A function needs to run on a specific container. This could be either in Docker or on a local container. We will use the local container to avoid depending on Docker. That adds a lot of extra dependencies that we don't need. And it will run as a web process. The web process will expose an URL with a port, and you will be able to invoke the function. That's the second step. Invoke the function from the CLI. That invocation is performing an HTTP request to the function, sending the context data, like the authentication, etc. This is already embedded in the execution, so you can perform the operations within the authenticated context. So we are going to use the Salesforce CLI to start the function and invoke the function. How can we start the function? Go to the functions folder, in this case Postgres.js, execute sf run function start. This will start the function locally. Right now it will run on my computer and on another terminal. As you can see here, the function has started, and in another terminal, I am going to invoke the function, doing sf run function, giving the URL is going to run on localhost port 8080, and specifying a payload. So this payload is going to be the information that comes into this data property. And the payload, it is a JSON object. Right now, I don't need an input. I am not provided any input parameters, so I am sending an empty payload. If I execute this, it will trigger the function and give me information. But you are going to see something that is going to happen here, and I love when things fail live. This gives us a very great chance to learn what are we missing. As we can see here, this is telling us, hey, warning, there is no connected org or target org found, so the context will be partially initialized. You can create functions that doesn't interact with Salesforce at all. That's okay. It depends on the use case. So right now, since we are trying to access Salesforce, this will fail. And immediately, of course, we are getting an error. So what we need to do is log in to an org. So let's log into an org. SF login org. Let me see if with SF login org works. Let's log into my trial. Let me type my password correctly. Thank you. Now I authenticated my org. And let me see if this works. Please work. It doesn't work. Okay, so let's execute the sf emp list. I am not getting the default here, so let's get the default. FX trial, it's the one we need. Let's pass that org. Now it is using FX trial as an org to pretty much authenticate the context, and you can see that now we get data from the org. We are getting 2 accounts with their specific IDs and names. And that's pretty much what we are running. Select the ID and the name from the account object. Alexander is asking, in the body of this function, we can query any DB other than Salesforce, correct? That's what we are going to do right now. That's what we are going to do right now. So the data API that comes from context is the SDK to interact with Salesforce data. But what I want to show you is how can we access other databases, specifically Heroku databases. The thing I'm going to be telling you applies for any other database that is deployed in the cloud, but I have Heroku at hand, so it's going to be easier for me to teach you the concept. And also, we released an integration that from the CLI is going to be super easy to connect an Heroku database to a Salesforce function by using the add-ons attach command that already exists on Heroku. But first, let's create an Heroku database, a Heroku Postgres database. So let's stop the function, exit the terminal, and we can do everything from here, from the terminal. Well, let me go and open this larger terminal. Remember that I told you if you need a Heroku Postgres database, first you will need an Heroku app. Let's create an Heroku app. Let's create an app. Let's call it codeLive PGDB. Let's hope nobody has created an application with this name, and it seems nobody did it. So we have codeLive PGDB as our application. This application is going to have our Postgres database. How can we create that Postgres database? So Heroku has this marketplace of add-ons called the Elements Marketplace, something similar to App Exchange, but for Heroku. There is one add-on that is official that we maintain and support, which is Heroku Postgres. You can create an Heroku Postgres database for free. As you can see here, there is a free version, which is the hobby development version. What are the limitations? Pretty much, there is a limit in the number of rows you can have in this database, which is 10,000. And the limit in storage capacity, which is 1 gigabyte. For demo purposes, this is going to be more than enough of what we want to do. How can we create that database? Heroku is giving us a command. So here we are creating an add-on called Heroku PostgreSQL, and the plan that we are choosing is hobby dev. For the app, codeLive PGDB. So we are creating a PostgreSQL database on that specific app, and right now we have a database that has been created, and it will give us an environment variable with all the connection string that we need to connect to that database. We can check it by running Heroku config and codeLive PGDB, and that's the connection string. Please don't steal this connection string because it is a very sensitive credential. But this is a demo, so don't worry. I'm going to delete this application, so nothing is going to happen. But make sure when you are going to push this code to GitHub or whatever, that this credential is not like pretty much hard-coded in your source code or on any file, because this is sensitive. But for the more purposes, it is good here. Okay, so that's the environment variable that we will use to connect to the database, right? So let's do something with this, and we can do two things, like create an environment variable or create a .env file. Let's create a .env file. So Heroku config gives me a shell flag that pretty much gives me all of the configuration on a shell format. So I can create it or send this output to a file, for example, a .env file. So it will load all of the environment variables using a specific configuration. So I can send the output of this file to the output of this command to a file called .env. And here we have the connection to that database. Since the Postgres JS function, it's a node folder, I'm going to be using a library called .env to pretty much require that .env file and set up that environment variable in our environment. This is for local development only. Then we will see how can we attach that on the compute environment. So let me install .env. Let me install .env. I don't need to dry run. Okay. This is a dependency I'm going to be using just for local development. And also we need to install PG, which is the PostgreSQL driver. What are these? Let's go to npm and open the documentation for .env and for PG. So .env pretty much is an utility node that lets you have a .env file with different environment variables. You will require that library, and automatically it's going to fill the process.env properties with those environment variables. You can either use require or ECMAScript 6 modules. And PG is the PostgreSQL driver for Node.js or for JavaScript. So this is the one we will use to access the database. Okay, let's import. Let me confirm something. I am using module. So it is ECMAScript 6 modules. Okay, so let's do this parameter, which is the import.mconfig. Nice. And then we need to import the client from PG, right? So we are loading the configuration that it will give us the database URL that it's on our .env file. Oh, let's move it from here to here. Okay, because we need it on the functions folder. Nice. And the client that it's useful to connect to the database. Okay, so let's create the client connection. So let's create a client connection. And the connection string is going to be process.m.database URL. Awesome. And the SSL connection, to prevent authentication issue with Heroku, with the self-signed certificates, we are going to reject, to set false the reject unauthorized parameter. This is to prevent an issue that's happening when you connect locally to a remote database. You don't need this if you are deploying to the compute environment, but this is to prevent that issue. This is just to perform or to create the client, and then we can perform the connection by doing await client.connect. But wait, we don't have any tables to interact with. What shall we do? Let's create a very basic table on our project. So let's use the Heroku CLI to access that PostgreSQL instance by using pg-psql. This is going to use the Postgres CLI to access my database that lives on the codeLive PGDB application. Awesome. Now I am connected to my Postgres. I don't have any tables, and I need to create a table. But I forgot how to create a table. If you know how to create a table by memory, let me know. PostgreSQL create table syntax. Let's go to the documentation. Hello, documentation. Tell me how to create a table or give me an example. Or I will need to go ahead and check my notes. Oh, okay. I have some examples here. Let's do something simple. Let's create table invocations. Okay, we are going to create a table to store the invocation ID of every function. So let's create the table invocations, and the ID is going to be a bar chart of 255, and that's it, right? Let's do it easy. Bar chart without this C. Okay, I created a table, invocations, with one column ID of type bar chart. Awesome. Now we have a table to store information. So let's access that database and insert information. So let's delete this query. We don't need this query right now here. And let's create an empty results because we are going to use that for later. And let's insert information. Let's see if this works. So we are going to perform a query, client.query, to insert into invocations ID values, not event data ID. Let's do context.id. That's the invocation ID of my function. So every time I execute this function, I am inserting that value here. Let's change this to prevent SQL injection. Using perfect. This is way better. Using the PG query parameter. So I am pretty much injecting the context ID, the first position of this array here. So every time I execute the function, I am connecting, I am inserting, and then I close the connection. Well, let's close the connection at the end, because here on results, what we are going to do is await client.query, select all from invocation. So I'm inserting and returning to see the list growing, right? Let's see if this works. Okay, I have a couple of questions. Ravi, I see the functions are async in nature. Are there any timeout period for the functions call? Yes. When you call the function from Apex, you can call it on two different ways. One is synchronous and the other one is asynchronous. When you do the synchronous Apex invocation, you have a 2-minute timeout. When you do the asynchronous Apex invocation, you have a 15-minute timeout. You can get more information about that here on the documentation. You can go to the Salesforce Functions documentation, and there is a link called Understanding Function Limits. It will give you not only the API limits that functions has, but also the execution of, for example, the 15 minutes, which is the synchronous invoke function, the size of the payload from Apex, how many functions you can invoke simultaneously, and the difference between asynchronous and synchronous. So this is a very good way to learn about those things that I already told you. They are in the documentation on the Understand Functions Limits section. Okay, let's continue with what we are doing. So we are connecting to the database. We are inserting a value and we are reading a value. Remember that this will work to any other PostgreSQL database where you can have the database URL, pretty much the connection string. But we are using Heroku. The second option, which is connecting using the CLI, it's only for Heroku. And I'm going to be showing you later if we have time. So let me try this. Let's start the function locally. So this will run the function locally. Let's hope it doesn't fail. If it fails, it's because of this. Import Postgres. We need to import it differently. Don't worry. This is easy fix. Import Postgres from Postgres. And then it is get the client and extract it from that variable. That's it. Easy fix. How I know this? Because I got the error and the error told me how to fix it. Okay, I have the function running. Let's invoke it. And I'm going to be looking for commands. Nah, let's not look for commands. I'm going to teach you a cool thing. You can create a JSON file, let's say payload. With JSON information, and from here you can trigger the invoke command. This will execute this payload and call a function. So this is a good way to have like a complex payload and execute the function from Visual Studio Code. And here you can see that we have some information, but we are getting a lot of noise. Let's just get the rows property. So let's restart this. Instead of all of the results, let's get the rows as results. Restart our function. and sf run function, give me the payload. And here, if I execute, I am going to insert a new ID and get all of the IDs that are on that table. So I already connected Heroku, Postgres with my function, right? So how can we do like the integration on the compute environment? So what is a compute environment? The compute environment is where I deployed functions that are going to be integrated with a Salesforce org. So those functions can be triggered by Apex. So I have 9 minutes. Let's see if I can do all of that in 9 minutes. We have a project. We need to create a Scratch org. Let's create the Scratch org. Since I am a little bit lazy, I'm going to be pasting the command to create the Scratch org. So let me go to the main folder. So I'm going to create a Scratch org from the Scratch org definition. I am setting up an alias, the duration for the Scratch org, and I am setting the Scratch org as the default org for my project. I need to log in, so let me log in. I'm using SFDX this time. The SF command can create Scratch orgs and all of the stuff, but it is in beta right now, and I prefer to use SFDX for this because I know it is not going to fail. Effects, I'm joining, I'm logging in. It is authenticated. Awesome. Now I can create my Scratch org. I created my Scratch org. It will take a little time, but this will work. Once I create the Scratch org, and what I am creating a Scratch org is to be able to deploy an Apex class to trigger the function. I will create the Apex class to trigger the function, and that function is going to be deployed to a compute environment. So let's see if everything works in 7 minutes. I'm nervous, but we can make it. Okay, I have the Scratch org. Let's create the function environment. To create the function environment, I need to log into the functions account. So here I am on the function account screen using the same user. I log in. Now I am authenticated. Awesome. So I will be able to create a compute environment. So let's go ahead, create compute. This compute is going to be connected to my org. So the compute environment where the functions are going to run on this elastic environment are going to be connected to the org. And I will give an alias so I can access logs and get information from that specific compute environment. So I created the compute environment. Let me list the environments here. Okay, I have the compute environment and I have the Scratch org. Fantastic. Now let's deploy the functions. So to deploy the functions, since this is using pretty much the same mechanism as Heroku, I need to have everything on a Git repository. So let me add this on the Git repository. It doesn't need to be on GitHub, just Git. Let's connect, initial deploy. I am committing everything, and then I will be able to deploy the functions to the compute environment connected to that org. This is going to check all of the functions that I already created on my project and push the functions to the compute environment. This will take a little time. Meanwhile, let's create an Apex class, right? So let's create an Apex class, create Apex class, and this is invoke function. And let's have a public void invoke method. Why not? Let's do a static method so we can execute it easily from the CLI. So how can we trigger a function from Apex? So first, we need to get the reference of the function. How can we get the reference on the function? We have access to a function's namespace, and that function's namespace can allow us to get a function by name. What is the name of the function? So the name of the function is the combination of the project name, in this case Heroku Data, dot the function name. In this case, we are going to the project TOML, which is the function definition project, here in the project.js folder, and it's called Postgres.js. So I have the function definition. Then I need to get an instance of the function invocation. Invocation. And for that, I will execute function invoke with the payload. So here I am sending the payload. And then I get the response, which I can get it from the invocation. And let's execute this and print it out to our pretty much terminal with system debug. So I'm getting the function, I am invoking the function, I am getting the response. Perfect. Let's deploy this sfdx for source push. Let's submit this Apex class to the Scratch org. Awesome, and then execute it. Force Apex execute, and this is called invoke function dot invoke, right? This should fail. Why? Because I have not connected Heroku with my compute environment. So there is no way for me to get the information. If we see here, I am not getting the response I am expecting. So how can we connect those two things? So first we need, and I share a blog post which is called Heroku Data in Salesforce Functions that teach you how to do it. So first, you will need to add your Heroku user as a collaborator on the project. So I'm going to add the collaborator. In this case, is going to be my Heroku user. So I can attach resources. So I am adding my account as a collaborator on my functions account. Perfect. Then I need to get the name of the compute environment. So let me get the name of the compute environment, sfm list, not truncate, so I can get the full name of the compute environment. And this is the name of the compute environment. And let me put it here. And then I need the name of the Postgres database, and this is Heroku PG info, and the application where we have the Postgres, and this is the name we are looking for. Okay. So let's take a look at something. First, let's get the environment, get the list of variables of that compute environment. If we see here, we don't have any config variables. So we are not setting up anything. Now what we are going to do is use Heroku to transfer the environment variables from my application to this compute environment, specifically the PostgreSQL one. So we will use Heroku add-ons attach. So Heroku add-ons attach the name of the add-on, which is going to be the PostgreSQL, and the compute environment, which is this name that we got from SFM list. Now, if I list the environment variables from my compute environment, I get the database URL. So now those two are connected. When those two are connected, I might be able, and let's hope this works, I might be able to get, okay. Why this is taking so much time? Let's execute this on the developer console. I think it's faster, and we can call it for today. So let me see. Connection is a little bit slow, but we will try. Yeah, this is pretty much the compute environment is stored in Heroku, but it's a different API. It is a different infrastructure. It uses like the same Heroku pretty much technologies, like the build packs, some of the APIs, but it's a team dedicated just for functions. And for some reason, my connection is not working. I am not even able to open my developer console here or execute Apex locally. Yep. There might be something with the tooling API right now because I am not able to do either or the other. Neither execute Apex code here or from the org. So I will owe you that. We can revisit next week so I can go ahead and show you a full project, a full demo when I'm using like a real database with a lot of data connected to a Salesforce application, showing you how I'm doing those queries, and try this example that for some reason is not executing and it's not letting me do anything here. And that's pretty much what I had for you all today. So make sure to check the resources. Yeah, timeout. As you can see, it decided to fail at the end of the stream. So thank you for joining. Thank you for getting back to codeLive. Remember, go ahead to the developer.salesforce.com website. Click on the Salesforce Functions Developer Center under the Discovery menu. Here you are going to find a lot of different resources to learn about functions. We have Trailhead modules, we have videos, we have a lot of information for you all. And stay tuned because next week I am coming back showing you how to do this using Heroku Redis, how to access Redis data store from a function, and I will show you a full demo that I already built accessing PostgreSQL data from a Salesforce app. I'm using Lightning Web Components, platform events, CDC events to integrate functions with an application. And stay tuned. Thank you very much for joining, and see you on the next one. Bye-bye.